Charles, I will be the lecturer for this course throughout this semester. Any questions you guys have about this course, please feel free to contact me by email, Skype, Zoom, or phone 24/7. Right? I've given you my office phone number as well as my home phone number. Right, so the course website for this course, the website for this course is this one. I hope you can see, all of you can see this. This is the website for this course. So there's no need for you to go through Blackboard to access this website. You can you guys hear me at the back? Okay. You can just bookmark this. You can bookmark this in your laptop or iPhone or iPad that you're using. So you can go straight. You can go straight to this website, and this website contains everything that you need to know about the course. So, for example, if you click here, this document gives, among other things, the full timetable for this course. So for the first week, we are in week 7 Feb to 11 Feb right now. So these are the sessions. These are the sessions that you need to go to. There is a review session which is currently taking place, and one of these computer lab sessions, right? And if you haven't, I hope that most of you guys have been to one of these, and if you haven't, please come to the one today. It's a computer lab session today from 2 to 3 p.m. in Alan Turing G105. Okay, so you must attend one of these computer lab sessions, right? So that. And the lab session is based on this document here. This is the document. You will get a copy of this document when you come to the lab session. Next week, this is the timetable for next week. So we have a review session 10 to 11 next Friday, and then you have tutorials in one of these times. So please go to the one that you're allocated to. Right, and for some reason, if you have an emergency or something, you can go to one of the other sessions. But in any case, please make sure that all of you go to at least one of the sessions, right, every week. And these sessions will be based on this tutorial sheet, right, on this tutorial sheet, right. So please, before you come to the class next week, the tutorials next week, please try to attempt these questions, right? Okay, before you come, and then I'll try to go through the difficult ones, right? And this is the week after next week, and so on. So every week you have a review sessions as well as 6 tutorial sessions. Some of the tutorials are in a computer lab and others are not. Like next week, the sessions will not be in a computer lab, right? Okay, guys, so, okay, let me talk about now these are my contact details, as I said before. I hope all of you have taken probability 1, which is a prerequisite for this course, right? It was a course that was taught last semester, semester 1, right? And these are contents of the course, feedback. Right, now assessment. This is an important part of the course. You will have quizzes every week. Starting next week, there will be quizzes every week. And each quiz is worth 1 mark, 1 out of 100. Right? So for example, the quiz that is due next Friday by 11 a.m. is this one here. It's not difficult at all. I mean, so this quiz is due. This is the question. There are 4 possible answers, right? And you choose the answer that you think is correct, and you should input your answer into Blackboard. So when you log into Blackboard, you will see the same question with the same possible answers, and just go and input your answer, what you think is the correct answer. And you will get only one attempt. You will get only one attempt to input your answer. All right, so make sure that you think carefully before you input your answer, right? And so you get either 1 mark if your answer is correct and 0 mark if your answer is not correct, right? So so the deadline for this is Friday, 18th of February, 11 a.m., right? After this time, I will send you an email saying whether your answer was correct or not, and also saying what the correct answer was, and also saying how I got the correct answer, right? So I will send you guys an email after this time next Friday. So that's quiz 1. Quiz 2 is similar. This is quiz number 2, right? And so on. So every week, every Friday, you have to submit a quiz using Blackboard, right? And each quiz is worth 1 mark. So you have 10 quizzes worth 10 marks, right? And up on top of that, there will be our coursework, which is contained in this link, that's due on Friday the 20th of May, which is the last day of the semester. And this ARC coursework is worth 10% of your total mark. So this is the ARC coursework. It's similar to last year's one, so it's basically asking you to do a data analysis, right? So if you look at the last year's ARC coursework, you will see how to do this, right? Okay. I mean, in order to do this ARC coursework, you need to attend the computer lab session. So that's why it's really, really important, I mean, including the one this week, that you do come to all the computer lab sessions. That will help you to do the ARC coursework, right? Okay, so this is worth 10%. Then finally, there will be a final exam. There will be a final exam in May or June of this year. That is worth 80% of your total mark. And the formulas that you need to know for this exam are contained in this. These are the formulas you need to remember for the exam. Okay? All right, guys. Any questions so far? As I said, if you have questions on the course or anything related, I mean, I taught this course for the last 4 years. Any questions, just feel free to email me or contact me by any means 24/7. By email or Skype or Zoom or phone. Or I'm also happy to see you in person in Manchester. If you want me to go through some difficult questions, or if you have difficulties following the course, I'm happy to meet you and provide you personal tutoring. Okay? All right? All right, guys. Okay, so that's the course syllabus. Then every week this is week 1. Every week I ask you to listen to the videos before you come to the review session. So I hope you guys. So these are the videos for week 1. There's a welcome video. There's a video about what is statistics. There's a video about trends in statistics. There's a video about elements of statistics. There's a video about methods of sampling, variables, independent events, sample mean and variance. So I hope you guys I hope you guys watched all these videos before right? Because I mean, I'm not going to spend my time going through these videos one again, because you should, before you come into the review session every week, you should watch these videos, right? Then I will do during the review. Now, as you can see, there's nothing in this link here. Like, as you can see, there's nothing in this link, and there's also nothing in this link, right? And after the review session, I will upload the material for these two links, right? Okay? It's kind of stuff I'm going to cover right now, okay? So that's for week 1. Week 2 is the same thing. Next week, I would like you to watch these videos. There are 1, 2, 3, 4 videos. One on summary statistics, graphical displays, normal distribution, and the binomial distribution. So please watch these videos before coming to the review session next Friday, right? Then I will go through them stuff with you, right? And so on. The same thing for week 3. The same thing for week 4, and so on, right? And these are quizzes from 2018, 2019, so you may look at the kind of quizzes I gave this year, and these are quizzes I gave 2019, 2020. These are quizzes I gave 2020, 2021, right? And these are our courseworks from past years, including last year, right? In-class test, this is not relevant because there used to be an in-class test for this course, but I have decided not to have it anymore, right? So there will not be an in-class test for this course, right? Okay, and then the final exams. So these are the final exams from 2015-16 to the last year, right? So you can see the kind of exams people used to sit and the solutions. You are given the full solutions for each exam paper, right? And finally, there are some books I have uploaded here. So there's no need for you to buy any book or borrow any books from the library, because these are the 4 books that are recommended for this course. The basic course in statistics. And 3 other books, right? So, and if you like me to upload any other book, please let me know. Like, if you think there are other books that are good for this course, and you would like to read those books, I'll be happy to get a PDF file and upload them here, right? Okay? So there's no need for you to go to the library to read books or to purchase any books, okay? All right, guys, any questions so far? Raise your hand or just speak. No? Are you sure? All right, now what I'm going to do now, so let me go to the top. What I'm going to do now is I'm going to quickly go through these 6 videos. See, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 videos I asked you to watch, right? I'm going to go through. I hope you actually did watch these videos, right? So I hope. So I'm not going to spend my time. The first video was about what is statistics, right? This is the first video I asked you to watch, right? I hope you guys did watch this, right? And this is the second video was about trends. These are 4 areas. 4 areas that are popular in statistics right now, right? And these are 4 elements of statistics: the population, the sample, the parameter, and the estimate. And I did 2 examples on it. This is the first example I did, and this is the second example I did, right? Okay, the next thing I did, the next video I asked you guys to watch is about sampling. There are many different sampling, right? But the 2 of them are sample simple random sampling with replacement and simple random sampling without replacement, all right? And I did an example or two. This is one example I did, right? Then the next thing was variables. Basically, there are two types of variables, qualitative variables and quantitative variables. Qualitative means color, gender, things like that. Quantitative can be discrete or continuous, right? Okay, discrete means like the things that you can count, like 1, 2, 3, etc. Continuous means things like height or weight or rainfall and things like that, right? And the next thing was, for quantitative variables, you can define things like the probability mass function if the variable is discrete, or the probability density function if the variable is continuous. You can also define the CDF, or the cumulative distribution function, for quantitative variables, right? And this notation here means the expected value or the population mean of the random variable x. This notation here, defined as this, is the notation for population variance, and is defined differently depending on whether variable is continuous or discrete. This is the notation for the standard deviation of a random variable x. Okay, and this is the notation for the nth moment of a random variable x. It's also known as the nth population mean, right? Okay, this is an example I did. I hope you guys watched this. This is the second example I did, right? The next video was about independent events or random variables. Now, you did probability 1 last semester. You would know that 2 events are independent. If this is the case, n events are independent if this is the case. And similarly, you say that 2 random variables are independent if this is the case for all x1 and x2, and n random variables are independent if this, sorry, it's cut here, but if this is the case for all x1 to xn, right? Okay. And a random sample is basically a sequence of variables that are independent and identically distributed, right? So they are independent and they have the same distribution function, right? Okay. This is an example I did in the video. I hope you watched this. And this is another example I did in the video, right? And the final video, I think this is the final one, yeah. It's about the sample mean and the sample variance, right? So if you have a data set x1 to xn, and the sample mean is defined by this. The sample variance, there are 2 different formulas depending. The first formula here is known as the biased version, and the second formula is known as the unbiased version. I will explain what these 2 mean in a different session, but unbiased, it means is better. Biased means is not good, right? So usually people prefer to use the unbiased version, but in some situations you need to use the biased version. And again, I will explain that later on in the course, right? Okay. Now the next is the population mean of sample mean. This is, I mean, some of you found this confusing. When I say the population mean of X bar, remember X bar is just simply, you take a sample and take the average of it. That's X bar, right? But if you do that, if you repeat that process, say 1,000 times, say 10,000 times, or 100,000 times, you get 100,000 different sample means, right? Every time you draw a sample, you get a mean, right? And if you repeat that, say 10,000 times, you get 10,000 sample means. Now, when I say population mean of X bar, what I mean is the average of the 10,000 sample means, right? That's what I mean, okay? I know it's kind of confusing to say that population mean or sample mean is the wording is kind of confusing, but that's what I actually mean, right? You repeat the process of taking the sample mean many, many times, right? And each time you get a sample mean, right? And then you take the average over the number of times you repeated the process. And that is the population mean of the sample mean, right? Okay? So it can be shown, I hope you followed the math here. The mathematics shows that the population mean of the sample mean is equal to mu, where mu is the population mean of X, right? Okay? And similarly, the population variance of X bar is the same idea, right? You have the sample mean. Just by taking a data set, you take the average, that gives you the sample mean. But if you repeat that process, say 100,000 times, you get 100,000 values for the sample mean, right? And you take the variance of the 100,000 values, that gives you what we refer to as the population variance of sample mean. And if you do the math, you get the variance of X bar. You get the variance of X bar equal to sigma squared divided by n, where sigma squared is the population variance of X, right? So I did one example on this, and this is the second example I did, right? So those are the videos. I went through them quickly because I hope all of you guys did watch the 7 or 8 videos I asked you guys to watch. So if you have not watched them, please, when you go home today, please do watch those videos in full, right? So you know what I was talking about today, right? All right, guys. So now what I'm going to do in the rest of the session today is to do some examples on the stuff I was talking about. So I'll start with example 1. I hope you can read my writing. Let me know if you can't read my writing. Right? So this is the first example I'm going to talk about. So here you have a random sample from a distribution with this. Remember, this is the notation I use for the probability mass function. So what you have here is a discrete distribution, right? A discrete distribution with the probability mass function equal to 1 if x is equal to a and 0 otherwise. The question is to find the expected value of the sample mean and the variance of the sample mean, right? So I'm going to use the formula that I just showed you to find the, let me go here just a minute. To find the expected value of the sample mean, I will use the formula at the bottom of this, which says that the expectation of x bar is equal to mu, where mu is the population mean of x. So the first thing we need to work out is what is mu, right? So mu is the expected value of x, right? Which is x follows this PMF, probability mass function. So this is going to be A times 1, right, plus 0, right? So your mu is A. Okay? So hence, the expected value of X bar, right, is equal to, using what is on the middle screen, right? The expected value of X bar is equal to A. Yeah? You follow, right? Okay. Now, to answer the second part of the question, let's go back to the okay, here we are. Okay. Let's go back to this, right? So according to this, the variance of X bar is equal to sigma squared by n, where sigma squared is the variance of X, right? So we need to figure out what sigma squared is. Sigma squared is the variance of X, yeah? And the variance of X, as you know, is expectation of this minus the square of the expectation, right? Now, the expectation of X squared, right, is, once again using the probability mass function, is going to be A squared times 1 plus 0, right? And the expectation of X, we already worked out, is to be A squared. So this is 0, right? So the sigma squared is equal to 0, right? So hence, the variance of X bar, using what is in the middle screen, is going to be 0 divided by n, which is 0. Are you guys okay with this? Yeah, so the answer to the question is that the expectation of X bar is equal to A, and the variance of X bar is equal to 0, right? Yeah. There's no need for you to copy this unless you really want to. I will make a scanned version of everything I've written down and upload it to the course website, right, which I just showed you, right? Okay. So that's one example. Let's look at another example. So this is example number 2. Right, so here we have a random sample from a distribution that has a continuous distribution with a PDF equal to A times X to the power A minus 1, where X is between 0 and 1 and A is positive, right? The question is once again the same question, that is, we want to find the expected value of X bar and the variance of X bar. So in order to find the expected value of X bar, we need to find mu. We need to find mu, which is the population mean of X, right? So let's see how we can do it. So mu, which is the mean of X, or the population mean of X, right? Now, because you're dealing with a continuous variable, what do you need to do in order to find the expectation? What do you need to do? Integration, yeah. So you integrate from 0 to 1 of X times the PDF, which is okay. So A is a constant, so you can pull it outside, so this becomes the integral of X to the power A is pretty basic, right? Yeah. And you should take the limits. The limit at 1 is 1 divided by A plus 1. The limit at 0 is 0. So mu is equal to A divided by A plus 1. Right? So hence, in order to answer the question, right, the expected value of X bar, the expected value of X bar is equal to A divided by A plus 1. Okay, guys, right? So that's the first part. Now, to do the second part, we need to use this formula here, that the variance of X bar is equal to sigma squared by n, right? So let's see how we can do that. The sigma squared is the variance of X, right, which, you can see it, yeah, okay, is equal to the expected value of X squared minus the square of the expectation, right? Now, to find the expected value of X squared, you need to integrate from 0 to 1 of X squared times the density function, which is this. The expectation of X we already know, right, is this case. So it's going to be yeah. You guys okay? Now, let me remove this. This integral here, what we have is A times the integral from 0 to 1 of X to the power A plus 1 okay, the integral of this is straightforward, so it's going to be yeah. Now, taking the limits, you get this. So finally, the answer is A divided by A plus 2 minus A divided by A plus 1 squared, right? So that's the sigma squared, right? So to find the variance of the sample mean, we're going to use this formula here in the middle screen, right? This one here. So this implies that the variance of X bar is going to be 1 over n multiplied by a over a plus 2 minus the square of this. Okay, guys, are you okay with this? Any questions? Yeah? All right, so that's, you okay? Yeah. You can actually simplify this further, but I'm sure you guys you know enough about math to simplify this. It's possible to simplify this further, right? Okay. All right. Now, so those are two examples on random samples. Or sorry, trying to find the sample mean and the sample variance of sample mean. All right. The next thing I'm going to talk about is I'm going to talk about some examples on random sample, right? So this is example number 3. Remember, random sample, as I said earlier. Let me go to the video on that. So if you look at the video on, here we are, this one here. See, this is the definition of a random sample. You say something is a random sample if they are independent variables and follow the same distribution, right? In other words, they have the same cumulative distribution function, and they are independent random variables, right? All right, so let's look at an example. So this is example number 3. Okay. All right. So this is the question that you have a random sample from a Bernoulli distribution, and the question is to find this probability here, right? Now, do you guys remember what a Bernoulli distribution is? This is something you should have covered. You do or you do not? You do, right? Just a minute. Give me something I forgot to mention. If you do not, the following may help, right? Let me go back to the course website, which is this is the course website. If you go to this link, there's a link called Common Probability Distributions, right? If you click on this link, it gives you the common distribution that you will encounter during this course. So, like the discrete uniform distribution. This is the PMF, and these are the formulas for the expectation and the variance. The Bernoulli distribution, this is the PMF, and the expectation and the variance. Then the binomial distribution, the geometric, the negative binomial, the Poisson, hypergeometric, multinomial. And it also gives a range of continuous distributions, including the uniform, the exponential, gamma, chi-squared, variable, Pareto, beta, normal, and so on. So it gives a variety of things. So you may find this link useful. So this link is called, just go back, the link is called Some Common Probability Distributions, right? So you can click on this link to find out about the distribution that we are talking about in this course. And also, if you want to know, excuse me, the notes that I'm using for this course are handwritten, but if you want to know the printed version of the notes, this is the printed version. I know some of you like to have printed version, not the handwritten version. So if you want to look at the printed version of this note, it's this one here, right? So this is the printed version of the notes, but for the purposes of the exam and for the purposes of all the assessment that I will give you during this course will only be based on the stuff I've written down. I mean, in other words, that all the assessments for this course will be based on the handwritten notes. The typed notes contains a lot more detail. It contains a lot more detail than what you actually need to know for this course, right? Okay. All right, guys. So let's get back to this. Now the question is, if you don't remember what a Bernoulli is, right? If you don't, let me write it down. X follows the Bernoulli distribution. With parameter p, if this is the case, is x takes the value 1 with probability p, and it takes the value 0 with probability 1 minus p, right? This is something, well, this is already actually in one of the links I showed you right now. You should go back here and look at this link here. It tells you the Bernoulli distribution. Excuse me. Yeah, here we are. See, the Bernoulli distribution is this one, right? Okay, so this is the definition of a Bernoulli random variable, right? And if you want to know what the PMF is, the PMF, the probability mass function of X, is as follows. It's equal to P, right, if X equal to 1, and is equal to 1 minus P if X equal to 0. Yeah, this is the probability mass function of a Bernoulli variable, right? And you can also write this instead of using the brackets. Some people don't like using these brackets here, so it's easier to write this in one formula, which is like this, yeah? Because if you put x equal to 1 into this formula, you get P, right? And if you put x equal to 0 into this formula, you get 1 minus P, right? So now the question is, let's return to the question is to find this guy here, right? So because remember, a random sample is a sample that are independent and identical, right? Because of independence, you can write this guy as using independence, right? You can write this as the probability that x1 equal to x1 times up to the probability that xn equal to little xn. Okay, that's using the fact that x1 to xn are independent random variables. Now, using this formula here, we can write this as this, right? As this, right? Okay, now combining all these terms here, combining all these terms together, you will get this to be P yeah, and if you combine, let me use a different color. If you combine all these terms together, you will get yeah. You with me, guys? Right? Okay, now you can write x1 plus up to xn as the sum of, using the sum notation. Yeah. And all the one, there are n ones here, right? There are n of them, and they add up to n minus the sum of xi. So this is the answer. So to hope you can see this. Yes. So this is the probability that is equal to this, right? Can you see this or not? Guys, any questions? All right. So that if we have time, or we have a few minutes left, the next question I'm going to do, so this is example 3. Example 4, well, here we have the, are you familiar with this notation? This means the exponential distribution. So once again, if you go to this link here, let me show you the link. If you go to this link and look for the exponential distribution, this one here, this is the exponential distribution, and it has the probability density function given by this, right? Okay, it's kind of an abuse of notation here, because for an exponential distribution, the probability, anyway, let me show you. I'm kind of abusing the notation because for an exponential distribution, because exponential is a continuous distribution, the probability x equal to something is undefined. It's actually equal to 0. But for the sake of argument, let's keep this, okay? All right. So this is actually an abuse of notation, because this probability is actually 0 for a continuous. Anyway, if you use the density function, which is lambda times e minus lambda x1, this is what you get. And there are n lambda, so you get lambda power n e of minus lambda x1 lambda times x to the n, right? So this becomes okay, guys. So this is example number 4. So I hope you get the idea about a random sample. That is, a random sample is a sequence of variables which are independent and identically distributed. So if you're asked to work out a probability like that, you have to just simply use the independence property. All right, guys, so finally, before you leave, if you haven't been to any of the computer lab sessions this week, please could you come to the one at 2 o'clock today. There's a session at 2 p.m. today. So please come to this session if you haven't been to any of the computer lab sessions. Okay? So I'll see you guys. Have a great weekend. I'll see you next week otherwise.
These review sessions are part of the recording.
Yes.
Where do I find them?
In the course web page, sir.
Oh, was it the last link?
Yeah, I'll put them in these 2 links.
So this one will be a rejoin.
Yeah, I will upload them in a few hours.
Okay.
A couple of hours time you will be able to see them. Okay?
Thank you.
Yeah. So this. Yeah.
So you know the quiz one?
Yes.
Is that material for week 2 or is that for week 1?
It's week 2 material, yeah. But you should be able to do it now. It's really simple. You should be able to do it.
Okay.
Yeah, you should be able to do it now. Yeah.
What do you have done?
Because I'm going, like I have a course, like since I'm an international student, the course is different. Yes. Yeah, it's just that like, since I'm not following a specific track, it's like I'm taking this at the same time as I'm taking,